Well, hello, good morning. Thanks so much for joining me here in my shop. I'm just going to start on this radio, and if this is the first of my videos you've watched, let me just comment a little bit about that. My videos are pretty much me working on this radio live. So yeah, it's recorded, but I don't do much editing at all to my videos. And so you pretty much see me work my way through the whole process from start to finish, including errors, mistakes, dead ends, all that kind of stuff. And also, because I don't write these ahead of time, I don't have a script or anything like that. Occasionally, I say things that are a little less than true, so you need to be careful about listening to me and accepting everything that comes out of my mouth. After all, I'm doing 2 or 3 things here at once, working on the radio, talking on the video, and thinking about other things too, like everybody. So this radio is presented to me by a customer. The comment was, the clock works. He didn't say too much more. I suspect the radio works too. But I don't know anything more about this radio than what you know now too, just looking at it. There's Electrohome, which is a very, very popular Canadian brand. I think it's in the States too. Very popular Canadian brand, at least from back in the day here. So Dominion Electrohome Industries, the full name of the company, in Kitchener. Kitchener is a city not too far from where I am here. Model PK-104, 35 watts. Has an outlet good to 1100 watts. Holy smokes, what would you plug in there? Have a tube list here: 12 AT6, 12 BE6, 12 BA6, 50 B5, and a 35 W4. Just a typical 5-tube lineup. 5-tube radio. It's missing one clock knob. These knobs are often missing or cracked or just gone. This one, it looks like someone has driven a nail through the, that's clever, driven a tack or a nail, a small nail, right through this, so the nail will engage with the slot in the shaft and stop this guy from turning. Often there's a plastic piece inside that goes down into the slot to grab it, but carelessness, so there isn't really there's a little piece in there. It's hard to see, a little key. Pull this one out. Oh, it just came right off, just like nothing. So there's no key visible in here. It's broken or worn away, and instead someone has cleverly pushed a nail, and you know what? It looks like a nail, and they've turned it into like a long rivet. It's got heads on both sides. Maybe it's 2 nails. Well, the basic message is this radio's on its last legs when it comes to these little knobs. Oh boy. A big thing about these radios is how they look. Most of these are going to sit on a shelf, and if they're played, it's played for demonstration purposes and not much more. This particular one, if the clock works and works fairly well, maybe you'd want it plugged in and the clock running all the time, maybe. So what it really amounts to is what the radio looks like. It's really a big part of it. Pull these off. So I'm looking to see if they're cracked at all in here, if there's any monkey business that's going on with them. They look normal. And that way we can also drop the radio out the back when the time comes. Okay, let's just see if you can see the pointer moving. So the string must be intact, and there's probably an on-off here. No, the on-off will be arranged in here. This is another problem with these vintage clock radios, is often the clock mechanism just doesn't work. The clock doesn't turn, or these controls don't work anymore, and you cannot turn the radio on or off. It's stuck in one position. So in a case like that, I sometimes install an auxiliary on-off switch on the back. So you can turn the radio on and off independent of the clock. It's got these big, it looks like inappropriate screws put in the cabinet. So this is a plastic. Is it a special plastic like Catalin or something like that? I don't really think so. But nevertheless, it's plastic, and it's almost certain to get more and more brittle as time goes by. And any stresses in it can kind of tug hard enough to initiate cracks in stress risers and other stuff. So you need to look for those things. But these guys are particularly bad actors. The screws going right into plastic. Very bad actors at cracking it. Let's take a look underneath here. So there's nothing underneath. Look at how beautiful the plastic is there. So the color in the camera is slightly different than what I see with my eye. You're seeing something that actually looks kind of a pinkish, kind of a really cool color, but in fact it's just kind of an ordinary red when I look at it with my eyes. Okay, so I wouldn't plug this in even though I suspect it's working. I would rather withdraw it and then plug it in. This screw is probably not supposed to come out. These feet are probably supposed to be caught on something. So it sets in and then you put the screws in to lock it. Probably. And sometimes there's sometimes these are threaded into a metal sleeve. Other times they're going right into plastic. This is a self-tapping screw here. So it's the right kind of screw, but I'm sure it's not original. It just doesn't look correct to me. Okay, now I think there's one more down here, wasn't there? One right here. So you want to tighten these screws up enough that they do their job of holding things in or together or whatever, but not so tight that they put too much unnecessary strain or stress on the plastic, or you're going to start a crack. And that's really what we're up against with these kinds of radios and making them last a long time. It's a cabinet. So it looks like the radio comes out and the clock stays back. That would be a little unusual. Yeah, that's what it looks like. Now there's no, it's not a wire. So I'm looking for wires getting tight. Looks like there's a lot of, I don't know what. Okay, get a nice grip on it. Here it comes. Here we are. And old radios like this, wires are often really, really stiff. The insulation can't be bent much more than just a little wee bit, or it starts to crack. These wires look stiff like that. They certainly are. These are quite stiff. Who's there? Peanut, are you there? Aha. Come in. Come on. Come on in. Peanut, come on in. Well, I haven't got too far into today's video before Mr. Peanut has showed up. Okay. So I try to be as respectful as possible of my cat, especially this guy here. He's is it time to go outside? Peanut. Peanut, hey, up here. Yeah, okay. Yes, my wonderful cat. Well, I'm going to have to go take him outside. I'm going to stop for just a minute here. Get him outside and get him happy. Okay, Peanut's outside. He's happy now. And he's out of my hair. I don't have much hair for him to be out of either. Okay. Bit of a dusty radio here. Just a kind of a thin film. dust. So interestingly enough, someone has taken the time to write all the tube numbers down here. Kind of see some of the writing there. Tube number 5, 12BE6. I don't think somebody would do that with this antenna in place. And I can see that this wire is resoldered right here. Probably here too. So someone has taken the antenna completely away for some reason. See, the antenna has been, looks like it's been re-glued with some kind of glue that doesn't go hard. What is that? Can you see that white stuff in there? I don't know what that is. Looks like toothpaste. And then there's a good old duct tape up here holding it up, holding it on. So the antenna's taken a bit of a beating, but I'm pretty sure it's the original antenna still. So I got 2 IF cans here. Anything else worth looking at? Not really. Whoever wrote down here, probably at the time these tubes were clean. You got a fair bit of dirt on them. So since whoever wrote those down there wrote them, this radio's been in some bad places. It would look like. I mean, if you look inside the cabinet here, that's really kind of a bad story in there. What is this? Some kind of liquid here? That has maybe wax has dripped out of one of the capacitors. Hey, there's a sneaky little piece of paper here. What's that? What is that? This is a treasure map. They have a treasure map here. Electrohome model PK-104 clockwork works. Hums good. Hums good. Hums good, eh? And why do they have this here? Why did they put this here? So I'm guessing this is a bit of a heat shield to keep heat from affecting the plastic. That's my guess on that. We'll put the secret note back. Now we know it hums good. Okay, so why would somebody have gone all the way to writing the tube numbers here, but this radio still hums? Now, I don't want to disturb these wires. I may in the end have to desolder these. They're not on a plug or anything. So I have to desolder them off the bottom here. They're going to break off if I continue doing this. Yeah, I think I'm probably going to have to remove them from here. So kind of, oh, I've seen enough already. Okay, maybe I'll flip it up this way. That might be a smarter move. No, these wires are not going to make it anywhere. Just flipping it right over. Rotate it this way. Or rotate it this way. There, that's a good starting point anyway. Now, make sure I get this on camera right away. So I want the positions of the wires to be noted. So we have the green one here, like a green paint mark on this wire, and we have a red wire. Oh, these two terminals are really tight here. Coming to this terminal, the center one here, and then the last yellow coming to the end one here. Are those two connected? Those two terminals connected there? Let me just see. Yeah, so there's a wire going between them here. Excuse me. Okay, got that on video. I'll be cutting. I'm pretty sure I'm going to cut away the clock. That'll present a problem with powering up this radio, but I'm sure I can figure that out. I can't be too tough. Now, surprise to me, it looks like nothing's been done under here. So someone did take the time to write the tube numbers on the top, but did not do any of the work under here. And can radios get much more simpler than this? I mean, how many parts are in here? There's next to nothing. So this is the guy causing the hum. I see why. You know why? There's very few parts in here because a lot of parts are jammed into this monster here, this package. So in here will be some capacitors and some resistors. This almost certainly is right at the detector, just past the detector volume control in that part of the radio. And trouble in these is common. This one looks nice, but trouble in them is common, and then you're in a bit of a jackpot trying to deal with something like this in a radio like this. Hopefully that's not the case. So nothing looking terrible under here. It's a bit of a higher wattage resistor here, kind of darkened a bit. So the name of the game of this radio, pretty sure right off the bat, change this out. And really, what's the use of even trying to play this radio? These need to go. There's only 4 of them. There's really only 5 capacitors, and the radios are renewed. So if I did plug it, I usually like to plug these radios in, turn them on, and hear them operate before I do anything. Sometimes they don't operate at all, of course. So then I make what minimal repairs I can do to make the radio operate to any degree. So literally, touching the antenna makes the speaker do something. And I get to that point, I feel a lot better about things. So I don't normally like working on a radio that has no... How do you like that? So, can you see this? Get a little pointer here. Can you see that little stub of wire there? You can kind of see it right here. There's a little half-inch of wire sticking out. Black wire, like this black wire. Cut. So that suggests to me that this has been replaced. And that this little stub is the wire, the old wire. And then look at the same thing here. There's a stub there. And I'll bet you the last one has a stub too. There's a red. So I think I know what has gone on here. The person who's replaced this, and this is so old it needs to be replaced again. But the person who replaced it, when they cut the old one free, they left the tail ends of the wires here for 2 reasons. 1, marks which terminal things came from so you don't get lost. And 2, if you leave a little bit of color in the insulation here, then you're actually marking which wire goes where too. So when you do the replacement, you get the black to the black and all that. It just makes it all really easy, rather than making diagrams or relying on your memory, which is bad news. And my own experience, I'm sure if you do this work too, if you think a wire goes somewhere, you look away to pick up a tool. When you look back, sometimes you just can't spot where you were. That happens to me a lot. So it happens to me in my house. Why did I come here? So I really do think we need to remove these. Looks like other person has desoldered these and removed them. I'll follow suit, because they're probably just tacked on. They'll probably just lift off if I melt the solder. So look at the power cord here, which this does not look like the original power cord to me. And hasn't done the best thing here. So the way this is done, the wire just comes up through the center of the plug and then heads for the screws. The problem with this is, over time, these screws can work loose and tug, 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 and slowly you start pulling back the wire, pulling it back. And eventually the bare copper area, the bare copper parts, can get close enough to each other to short. Kapowie. So this one's not near to shorting or anything. It's actually looks okay the way it is. It's just not done right. Maybe I'll straighten that out later. You see the power would be supplied here, and it's supplied here. It picks up the red wire. Red wire goes to the clock. This is probably the switched wire here. Whoops, you're just not quite looking up here. So in other words, the power The clock is run on these two, and then when you switch the switch to turn on the radio, this wire gets energized. This is the black wire. Well, I don't quite fully get it, but I'm not going to worry about it. I think for the sake of working on this, I've got to cut away these wires. And we'll have to just reconnect them later. As much trouble as that may be trouble. And I'm just going to cut them free because I made notes and an image of this stuff. Didn't I? I said I was going to desolder them. Let's try that. It's kind of dumb I cut that one. So I bet you this will just come right off. Big job for the small soldering iron here. As fast as my soldering iron can put heat into the joint, the heat is disappearing up the wires. Jeepers. Holy smokes, I'm going to melt the whole. So let me get a little solder here. We'll increase the heat transfer rate just by freshening up the solder a little bit. There. Ow! Hot stuff. Hot stuff. Not just tacked. Yeah, that's the three of them. Should be able to take the cabinet away. Yep. Okay, let me just set this over here. So it comes time to power up the radio. It will be a little bit of some figuring out to do. Okay, you know, there's not much more to say about this than 1, 2, 3, 4, 5 capacitors got to be changed, and there could even be weak or defective capacitors inside this thing too, unfortunately. So we'll start with this guy. Maybe I'll try powering it up after just replacing this, just for fun. I just like doing that so much. So he's a 200 volt, 150 volt capacitor. It's got 4 wires coming out the top. I only saw 3 at first. So it's got an 80 microfarad, 30 microfarad, and 10 at 25 volts. 3 capacitors to do it. So what now this one's all yay. I think right. I cut it and leave all these wires behind. So all the wires are coming to one central location where this was, and as soon as you remove this, you have the space, usually for your replacements. With any luck, we can just continue using these same wires. They're fairly flexible, in fact. Great. A little tough using this on the short wires here. So in Canada, the COVID rules, if you like, are tightening up very rapidly right now. And I think everybody's become convinced that there's no question another surge is developing, or wave, if you like. And you know, we really haven't fared all that well during the first one. But we did manage to bring it under control. We got rate down. There's 37 million people in Canada. We got rate down to a couple hundred cases a day, and stayed there. So I'm gonna have to replace this wire here. Can I get in there? But for the last couple of weeks, it's just been slowly rising up and up and up. And now we're at over 1,000 a day of new cases. So my wife and I, we've assessed our own rules on all this stuff. We've got our own guidelines that we've developed, and I'm happy to say we've been ahead of the public curve the whole time. We've started doing things that, look at this. There's almost nothing holding this wire on here. I don't want to take it right off, or I'll lose track of where it is, but this is just popping right off. This doesn't look so hot either. Looks like a cold joint, cold solder joint. I'm going to replace a little more of these wires. More capacitors. Okay, so we need some 160 volt guys. That's 10. Where am I? Big pot. Here we are. Oh, I have a few. So these are 40s at 160. If I want to get 80, I put two of those together. And then we're going to need 25 at a lower voltage. So it can be much bigger if I like. $22 at 250. Good. We'll do it. So that's what we need here. Now they all share a common negative. That's this. The terminal's right here, so I could potentially mount these capacitors right onto this terminal negative here, negative terminal, and get a pretty strong, mechanically strong spot here. So take the shorter ones. So I'll include this one. What happened there? And then what we would like to do is kind of mount this like this. Like that. and connect all these wires to all the other wires. 4 of them. How did I get to 4? Oh, because I'm doubling one of these to get 80. I'm doubling 2 of these to get 80. So if we make this the 80, look on here, according to what was done with this, the 80 is the red. So the 80 should be tied to there. So I just have to kind of make a logical choice as to when to start soldering stuff here. Bend this one up, bend this one up. So the idea would be to put it in something like that. Long wire here, which I'm going to probably replace. And this wire we want to get down here. So, this is the power coming right into the radio, and this lead's going to go right next to it, even if I insulate it. It's right on it. I've taken the original wire and kind of stuck it under here. Can I get on that original wire? Don't think I can get much out of this tool. Tiny tidbit. See if I can get a little more insulation off this, or I'll just replace this wire. Are. Okay, managed to pull that off, literally. So now, where's my capacitor? Where'd he go? Oh, it's right here. Okay. Okay. Tinning this might be a mistake. Make this so stiff I can't manipulate it. Now I'm not soldering it to this terminal. It's not my aim here. Nice big blob of solder here. Now, I've got a I've got 3 wires. Oh yeah, one is the black one we don't need anymore. I was having a moment of cognitive dissonance there. Well, actually, I'm not so sure that was cognitive dissonance. Now, I got 2 connections, 2 wires to hook up. One of them goes to the lower voltage, 25, and the other one goes to the higher voltage, 40. Oh my gosh, I may have hooked up the 80 to the wrong spot. No, I checked it. Red was 80. Red was 80. Is that red was 80? Let me look too close. Yeah, red was 80. Assuming the last guy did it right. And I think he did. So which tube is the output tube? Who's this guy? So that looks like Mr. Rectifier there. Japan. Let's just leave it out. This is probably the output tube here. 50B5. So the wire that comes from the capacitors over to this tube is the one that's doing the bypass. Look, this has come right off now. So I'll leave this out for now, and I need another little piece of wire here. Got a little chunk here. So we're coming from this terminal. See if I nick the wire at all. Nope. When you use cutters to remove insulation, you can just nick the copper wire ever so slightly, and then chances are it's going to break there. And you won't want that. There's a great big blob of grounding solder here, and nothing connected to it. solder that. Okay. I can do a little better job there. Ooh. Burning up the power cord. Oh, just look at that. Just ripped the insulation off the wire up here. Now I got bare wire ready to go on this contact. Okay, try that again. This is where I usually end up soldered to the wrong connection. I'm afraid a significant portion of my troubleshooting time is hunting down the mistakes I've made. Ton of solder here, but it's all dropped down. Yikes. Tugged on this when the wire was still hot, and that's why I ruined the insulation on it earlier. Don't tug on it. Okay, up to here. This one here. Insulation's broken here too. This tool can cut the wire as easily as strip it. You need a little finesse when you use that. Every time I guess I'm using that tool, the tool is breaking the insulation just above the cut point. It's a lousy wire. But I'm not going to worry about it this time. And now this is all set to short against the Didn't I say something about nicking the wire and then it breaks? Oh boy, we're going to run out of wire at this rate. That, I'm sure, was better. Did not nick the wire that time. I still got enough. Sure. Just gonna drop off. See what happens. Nope, stayed on. Okay. And this wire is ready to go. It's jumping to get there. Now, I'm not gonna want this. I guess I can twist it after. Okay, so this is sticking right up. Bits of wire sticking out. Invisible wire. Now it's sticking right up. Does it really matter? And there we are. This is almost shorting here again. Oh my god, it's terrible. That's terrible what happened there. That's just... Oh, what am I supposed to do about that now? Do the whole thing again. No. What I'll do is I'm just going to stick a little wee bit of tape in there. The wire has to move to short. To move that wire, you got to move this a long ways. Chances of it actually happening are very, very low. They're going to be even lower once I fish this in there. I don't like using black tape or this this kind of tape in situations like this. In a lot of these old radios, you'll find the odd taped connection, and it's done with friction tape, or we would call it hockey tape here in Canada. And my experience with this tape is really good. It kind of goes a little solid over time, and it's very rugged. It does not undo itself. This stuff, the stuff I'm using here, tends to undo itself over time. That stupid thing I'm doing. I'll feel better when it's there, though. It doesn't really have to be stuck to anything much. Okay, I have better feelings now. Should we operate this radio? So to operate this radio, I think the trick is to get the power here. This is the negative terminal, and the switch must be breaking it here. So which one was switched? Is it this one or is it this one? So there's a red from this terminal. Is there anything going from this terminal? Well, there has to be. Oh yeah, the clock, which I removed the clock wire. So it's from. So the switch is from here to here. So if I put a jumper in here, we're on all the time. If I install a bit of a switch here, how could I do that easily? I don't really need to, because I have enough switches on my bench to turn the power on and off quite safely. So I'm just going to put a jumper across here with this wonderful orange. Actually, it's just right here, isn't it? A bare wire would do the trick. Once again, it's damaged the insulation up here where the grip got it. I don't really care though. Something to realize about my stripper. Now we don't know about the clock. We don't know about the clock switches. We don't know anything about that. We're just going to know about this. I don't want to do this big. I don't want to melt that whole thing there. I'm trying to get it on a little wire down here. So heating up a connection like this with so much metal involved, it's hard to get the temperature high enough, and the chance of you getting a cold joint here is really high in situations like this. That's going to be good enough though. I plug this radio in, turn on the power to it, and it will come on. Well, we'll do something. We're going to find out. We're going to find out. Flip it over. Now again, if this is the first video you're watching, I have safety things going on in here, or I do things in a way that prevent big problems from happening. One of them is powering up a radio like this. If there's a big problem in the radio, or I've done something stupid, or there's some kind of short circuit ready to go, this tube, can you see? It's darkened up at the top and the bottom. You wonder, what exactly is that material that's collected on the inside of the glass? It's black, and maybe it's carbon. I don't know. So this rectifier tube runs fairly hot. There are literally components in the tube, you know, the metal part and the cathode. There won't be a cathode in this tube, I don't think. That it can literally vaporize metal, or have ions in here that end up banging into the glass and collecting on it. It's a high mileage tube in any case. That's really what I want to say. It would look to me like a high mileage tube. Okay. Are we ready here? So I'm going to plug this into a dim bulb system. Again, if you're new to my videos, this is plugged into a transformer. This is supplied 120 volts through a transformer here. There's the transformer sitting right here. That isolates it from the power system, and the power system ground in particular. This is a 5-tube radio. There's an inherent danger in touching the chassis while this radio's plugged in. It doesn't have to be turned on to have a hot chassis. But with my transformer, I cannot draw current between the output of that transformer and the regular hydro system. So theoretically I can have my hand on this and I can touch this piece of equipment. Look, I won't even do it even now. Too scared. So what I'm trying to say is, you're watching my videos, you're new to my videos, I'm not saying very much about what I'm doing to protect things, protect myself. I am doing things. Okay, so the volume is down. Has a really cool red light bulb in it. I think we're set. So over here you can see a couple of light bulbs here. This one's loose. It's not. This one's screwed in. The power that reaches this radio passes through the light bulb. The light bulb's in series with the radio, and that's my protection. We're going to hit the switch here. Throw the switch down. Power will go through the light bulb to the radio. If I throw it up, power goes straight to the radio. I'm not going to throw it up. I'm going to throw it down, and this light, all things being correct, the light will probably come on and go dull, and then as the tubes begin to conduct after they warm up, it'll brighten up a bit. Maybe, maybe not. Let's see. If it comes on full bright, I boobed up big time in there. Here we go. Okay, so it's barely on. I saw it. Just barely came on. Now it's gone down, and it'll probably. Let's keep our eye on the radio now. The radio's more exciting now. So I see it. One tube is heated up. If one tube's heating, they're all heating. They're all conducting. Listening for any sound now. The actual supply voltage to the radio is 114. That's within the normal range. Oh, what was that? A little click. Well, it's dead silent. Let's turn it up. tune it. So I'm pretty sure that would be 640, and it's right at the 640 spot on the dial. Another station, 590, it's pretty strong. Right here. Just tip the antenna. Another station, 680 up here, hard to get. So do you hear the swoosh? Do you hear the heterodyne tones as I tune? That sort of swoosh, swoosh sound. Can you hear that there's a heterodyne as I tune in? There's a heterodyne pitch. It's fairly high now. It goes down to 0 as I get it tuned in. All those things are indications of bad quieting capacitors, I believe. Hey, there we are. 680 at 680. Just listening, there won't be any stations to hear up here. I'd be shocked. Let me just listen to the noises. The volume was up pretty high there. Sounds like it gets a little quieter down at this end. Sounds pretty good, actually. Not bad. Okay, so it does make sense to go ahead and change out those other capacitors. It'd be interesting to find out how good or bad they are. And what happened to the red light? So the thing about these radios is they have a hard time with lights. There's two ways of doing them. One is a 120 volt full voltage light bulb. I think that's what this might be. Let's turn the power off. We don't need it on now. Or what goes in here is a 6 volt light or so, and gets its power from a trick that's played with the heater of the rectifier tube. They put a tap on the heater of the rectifier tube and play a little trick. This certainly looks like a 120 volt bulb to me. And is it any good? Just looking for my voltmeter. Here it is. Here it is right here. Are we any good? She's a gunner. She's done. She done. Okay, so boy, I think a little Christmas light would do it. That's a really weird looking thing, eh? Hopefully I've got some kind of bulb that'll work in there. Great. Okay, so I think that's going to be it for today. I see by the clock I've hit 1 hour. It's amazing how many of my videos come out to almost exactly an hour. I don't attempt to make them an hour long, but they seem to come out that way. So that's good. What's left here is replace the 4 capacitors and then do an alignment on the radio to make sure its performance is peaked. And that's the end of this guy. Thanks for watching today, and have a good day.